This video is the start of a series of my personal attempt of making a Redstone computer in Minecraft. So, what you see here is logic gates. I've implemented all binary logic gates into Minecraft. So here we got the NOT gate. So it takes one input and it has one output. So if you don't know how binary works, it's zeros and ones. Zero is off and one is on. So it's either true or false. So for NOT gate, what it does is just inverts the output. So if it's on, the other side is off. If the input is off, the output is on. So in Minecraft, when redstone hits a block, and if a block has a redstone torch on it, the torch turns off, as you can see here. So yeah, so for NOT gate, that's the most simple gate here. So for the rest of the gates is made using a combination of NOT gates, which is actually kind of cool and it's kind of intuitive and interesting. It's just very easy to explain, as you'll see. So that's a NOT gate. Over here, now we've got two inputs and one output. So if this is an AND gate, so if that means if the output is only on if both inputs are on. So if one is on and one is off, this will still stay off. Both of them have to be on in order for the output to be on, as you can see. So how this works, so we can do a little reverse engineering here. So if we want this to be on, both of these have to be off, and in order for both of these to be off, both of these have to be on, if that makes sense. So yeah, and that's exactly what we see when both these are on. This is on. So if both these are on, both these turn off, and this one stays on. So all cases, so you can see if this is on, this is off, but this one's not on. So if that one's on, which turns off this redstone torch right here. So that's AND gate, and for NAND gate, over here we have a NAND gate, which stands for not AND. So it's basically the exact same thing as an AND gate. It's just an AND gate copied and pasted over here, but with a inverter right at the end. So it's the same thing, but with an inverter. So if the output is always on, unless if two inputs are on, you can see it turns off when we turn both on. So that's a NAND gate. The next gate we have is an OR gate. So we got two inputs. So we got two inputs and one output. So let's see here. So if we want the output to be on, we want this to be off. In order for this to be off, we need at least one of these to be on. Not both of them, just one of them has to be on in order to turn the redstone torch off. So as you can see, it's only on if, well, just one of these has to be on in order for output to be on. So that's OR gate. Either or, it's just at least one of these has to be on. I think you get the idea. So if a NOR gate is the OR gate, so if NOR gate is actually the most simple gate to make, actually. So a NOR gate, all it's saying is none of them, NOR gate stands for not OR. It means it's only on if two inputs are off. So if at least one of these is on, you can see it turns off. So that's a very basic gate to implement. Now we're going into the more complex gates. So now we have the XOR gate. So how I implemented the XOR gate is, I just said it's an OR gate and a NAND gate. So OR and NAND. So one of these have to be on, but not both of them. If both of them are off, it's going to be off. If one of these is on, it's on. But if both of them are on, they're off. That's a definition of an XOR gate. So at the bottom here, what I did is implemented a NAND gate down here, and then I implemented an OR gate up here. That makes sense. Well, it's a NOR gate, but this is used to cancel this. So if a NOR gate is on, this is off. But if the NOR gate is off, this could potentially be turned on if it wasn't for the NAND gate turning off, if that makes any sense. So yeah, it's just a combination of OR gate and a NAND gate. In other words, I could probably change this to say not NOR and NAND. That's probably a better description of this gate, but it's whatever. So you can see the output is off currently. If I turn one of them on, it turns on. If I turn both of them on, it turns off. If I turn this off, it's on. So that's the XOR gate. So the XNOR gate, which is a not XOR gate, it's the exact same thing, but we invert the end. So it's a not or and NAND gate. So it's on if both of these are on or if both of these are off. So if I turn this off, you can see it turns off. If I turn this off, it turns on. If I turn this on, it turns off. If I turn this, if I turn both of them on, it's on. If I turn both of them off, it's off. Any other combination, if this was on, that one's off, it turns off. That one's on, if this is off, it turns off. So yeah, those are all logic gates implemented in Minecraft, and yeah, I'll be able to use these in future videos when I work on a Redstone computer. So I hope you enjoyed this short video. It's just something I'm working on. I've actually made a Redstone calculator before, but that was on Xbox 360, and unfortunately I lost the file, but I made them through these gates, which was cool. But yeah, I hope you enjoyed the video, and I'll see you in the next episode.